Hello, data pipeliners. This is Data Engineer One, and welcome back to another episode on Let's Write Pipes. Today, I have a super cool pipeline for you guys. It's a semi real time streaming Twitter pipeline. This pipeline actually pulls from the Twitter streaming API and pushes it through a Kedro pipeline in semi real time. It's a super cool pipeline. It has a lot of interesting tricks that I had to employ in order to get it working and I really want to show you guys what's in store. So it's really awesome. Let's go ahead and take a look. First, taking a look at the pipeline itself, we can see here that it's a non-traditional pipeline. It has some weird stuff going on for it, just like from the get-go. There's strange data sets that are hanging out here. This confirmed raw tweets. We've got these other data sets down here. We've got these data sets coming in. But I guess the first question is, what are we actually doing? Well, what this pipeline is doing is it's reading from the Twitter API, the streaming API, extracting words of those tweets, like the actual tokenized words. And then what it's doing with those words is it's just doing a simple count word. So it just wants to see how often does a word appear in this current stream. The word counts then get saved into a graphing function, and then we actually use Kedro's new matplotlib writer to write out the graphs that we can take a look and see the word counts. So now the question is, where is the streaming? Where's the streaming going on here? Actually, the streaming is hidden right here inside of the raw tweets data set. So this data set is actually an incremental data set, a little bit of a special incremental data set. Um, but the way that it works, and we'll just open up the code right now so I can walk through the code to show you how it works. But basically here, what we do is we actually set up a streaming API instance inside of the Kedro context. The reason why I chose the context here is there's actually several, but for experience, it's really good to add any kind of programmatic data sets, anything that you're adding like programmatically, just put it inside of the Kedro context so you have like a single place to look for all those kind of anomalous data sets. And so in this case, we have the Twitter stream, which is an anomalous data set. So the way that the stream works first is it, of course, pulls credentials from the configuration loader and then creates this auth handler so that it can authenticate with the Twitter API. I'm using TweePy in order to interface with that API. It's a really great Python library. It's been around for about 8 years or so, and it really did a good job here. So the way that the API works is that the Twitter stream inside of the TweePy offers an ability to attach a listener. And so what you have to do is you have to create your own listener that will listen to the stream. And whenever a tweet comes down the stream, the listener will be called and the data will be sent into the listener to be saved or to be processed however you wish. In our case, what we're doing here is we're creating a listener that also takes in a save tweet callable. So this callable function actually comes from the catalog save. What we're doing is we're just currying this catalog save function and then making it such that the Twitter data set that we're going to be saving into, that's the incremental data set, which we actually have a copy of here inside of the catalog, we're making sure that the data set here gets pulled in by the Twitter listener, and then it's used by the Twitter listener to save a tweet. Now, because we're using an incremental data set as the data set that we're saving into, we can actually just pass in a dictionary containing the current date time of the tweet being received by our systems, as well as the tweet data. And pushing it back in this JSON form. This is actually the Python dictionary form. And the reason I'm doing it like this is because, if you recall, the incremental data set requires ascending keys in order to make sure that it saves its checkpoint. And so any checkpoint that is saved, it says, okay, any keys that are lower than this will be ignored, and then any keys that are after this will be pulled in. And so that's why it's important to use that incremental incremental key. You can make sure that you watch that incremental data set video, compute your data sets incrementally for more details. And so here, we're saving the data into the save tweet, which is saving into the raw tweets data set. But if you look here, this data set is actually not incremental data set. This is a custom data set. So I actually wrote a custom data set called sr.io uncached incremental data set. The reason I made this uncached is because the Twitter API runs in the background in a threaded manner. So this is an asynchronous threaded manner. So it's a background multi-threaded process. You can see right here the async is true. And so what that means is that um, the any kind of functions that are used by this any synchronous functions that are used in an asynchronous manner have issues. And so one of the functions that Kedro relies on for the incremental data set is the cached data function. So if we actually look at the original implementation of the incremental data set, and we can scroll down, we can see here list partitions. This function right here gets the entire list of partitions that are available for the dataset to read in. However, by default, it uses a cache mechanism on that function in order to cache the list of datasets that are available to it. This is not thread safe, and as a result, I ran into a huge bunch of issues where the data, even though I was saving new data inside of my folder, Kedro wasn't reading it. And so I had to override this list partitions function basically by just copying and pasting the same code and then just removing the decorator itself. So removing this cached method decorator. I did the same thing also for the partition data set, where I removed the cache decorator on the list partitions, as well as I removed one function here inside of the load. So by default, the partition data set will throw an error if there is no data to load. So I just actually removed that error, and we are now just using partition data set as normal. And if there is nothing to load, then it'll just return a blank empty dictionary. Okay, so let's go ahead and continue down on this pipeline. So, what's happening here with this confirm raw tweets? So this is a little bit of a sneaky hack here because the way that confirms works, like if you use confirms in your pipeline, like for example, the way that I'm doing it here, what it does is it will just tell the data set to list all of the files that are available inside of its folder, pick the latest one, and then make a checkpoint of that latest one. It's assuming that there will be no files added after the fact. However, because we're doing it in a multi-threaded way, since the streaming API is constantly streaming into that folder, we have to instead explicitly set our confirm raw tweet. So the way that we do this confirmation is we actually do it inside of the extract words. When we get our tweets inside of our extract words, what we do is we just do some very simple stuff where we split the tweet out by words, we remove anything that's not printable, and then we output. But the very last key that we get a hold of, we output as well to this data set, this confirms raw tweets data set, confirm raw tweets data set. And this data set, all it is it's a simple text data set which points to the checkpoint. This is where you would normally find the checkpoint file inside the raw tweets. So we're actually kind of recreating our checkpoint function without having to override the incremental dataset method. And even though we did override the dataset method, the truth is that the checkpoint function on the incremental dataset does not have any contextual data. So it actually does not have any parameters, it doesn't have anything that's passed into it. So we actually have no idea which tweets we've already finished. So we actually must manually specify the checkpoint for ourselves. But once we do that, then the extract words works very nicely with the raw streaming tweets. And so as the pipeline runs, the tweets will like constantly in the background be populated into that folder, and then we can grab the new tweets. Okay, let's go ahead and keep on going. So extracted words, very simple data set. We just save out the words that we get. But count words. So if you look at the count words pipeline here, it's a little bit different. We're using previous word counts and then the extracted words, and then we're outputting to a word count. So what gives here? Well, this is actually a technique that I call chrono coding. There's no video about this quite yet, but I will make one in the future for sure. So chrono coding, the basic idea behind chrono coding is that you want to be able to save your state. So Kedro doesn't really have a good way of saving state between runs, right? There's no kind of like meta state, or there's no way to like refer to your old data sets because of the explicit requirement that no cyclic graphs are allowed. So Kedro relies on directed acyclic graphs. So you cannot have a circular dependency. But really, when you think about it, there is no such thing as a circular dependency if there is a temporal separation, right? This chronological separation. Hence why I call this method chronocoding. I'll save that. That'll suffice for now in terms of an explanation. But the way that this particular node works is it will count the number of extracted words. What it'll do is it'll just go through the entire list of words that were extracted from all the tweets, and then do a word count aggregation on them, right? And then it will save those word counts to this word count folder. Then, the next time around, when this node runs a second time, what it'll do is it'll pull in the previous counts of those words. And so the way that we do this here is we have a word counts, which will point to this primary word counts folder. And then we have the previous word counts that is also pointing to the same folder. But note here, the types are different. So with the incremental data set, the reason why we want incremental, of course, is so that we don't recompute those word counts later down the line, right? But if we were to use incremental data set with previous word counts, what would happen is that the checkpoint that is related to the word counts data set would override the previous word counts. Now, this might not necessarily be true. There may be an option inside of the incremental data set to override what the checkpoint file is. But at the very least, this way, we are instead using the partition dataset version. And again, I already showed you the uncached partition dataset version. But the reason why we want to use this partition dataset is because it will load all the files, only the paths, but it won't load the files completely into memory. And then we can choose exactly the file that we want. And in our case, for this particular function, we want to choose the very last file. And so if you look inside of the nodes here, you can see that the previous aggregate count is equal to the max value of the keys for the previous words. And then so once we get that aggregate count, we just overwrite whatever the stuff was there, and we add on any new counts for the new words, and then we return it in this form here. And because we're writing it out to an incremental data set for word count, so word count is an incremental data set. Because we're writing it out to word count incremental data set, it actually creates a brand new file for us with the current date as the file name. So it's actually super convenient, very, very useful. The current date as the file name gets the aggregate count data. So this means that we get the previous versions, like all the previous aggregate counts, as well as the new one here. And so again, this is really important for this previous word count idea, where we want to get the previous values from the system. Okay, and then last but not least, we have this create graphs function. So the create graphs function is very simple. All it is it's just using the matplotlib writer. So this is a brand new data set that was released in Kedro 0.16.0, where you can write out the matplotlibs that you write. And so we have one here, very simple one, where we take the word counts and then we just do an X values where the X values are the words, the Y values are the amounts or the counts of those words, and then we do a figure plot on that. And we also make sure that we take the top 10. So we don't do all of them, we just take the top 10. This will give us a figure, which will be the top 10 most used words in this particular stream, with the output also being a incremental data set version. The reason why we do that is just so we can have a history of our graphs. It's just a nice thing to have. Really quickly, I just want to note here, the question now becomes, how do we run a Twitter streaming API while at the same time running our Kedro pipeline? It doesn't really make that much sense, right? If you run a Kedro pipeline, it'll just go through all the nodes and then quit, which is obviously not what we want to do. We want to have a constant connection with the Twitter API. Well, the way that we do this is we actually have a custom runner. So we have a custom runner that makes sure that the pipeline doesn't die. It's a very simple runner. All we're doing is we are overriding the original sequential runner. So this is the default runner that comes with Kedro, that runs Kedro whenever you do Kedro run. And then what we're doing is inside of the run function, we're just putting a while loop. It's a while true. And while true, it's just going to run that pipeline. It's going to run the entire pipeline over and over and over again. I have a little sleep here for 10 seconds. And so this 10 seconds right here is the reason why it's only a semi-real-time pipeline, not a real-time pipeline. We do have a sleep of 10 seconds in between our runs. But after that sleep, it'll just rerun the pipeline again. So it's actually really, really cool. Something else that I want to note here also is the way that we instantiate the Twitter stream. So notice here, I actually use init Twitter stream as an instance function on the Kedro context. The reason I want to do this is because, of course, we want to get access to the configuration loaders as well as the catalog in order to save and configure our stream. But we also want to be able to initialize the stream when we want to. And in the case that we want to is whenever we call the run. So when we call the run function of our pipeline, we want to make sure that we are initializing our Twitter stream. So we do the init Twitter stream underneath the run function here. And the reason why you want to do it under the run function and not under like the init function is because if you were to open this pipeline inside of a Kedro notebook, like if you do Kedro Jupyter Notebook, then you would not initialize the stream automatically. And that's really good because if you want to just experiment and just look at the data, just experiment with the stuff that you already have available, you don't necessarily want to run everything over again. So that's the reason why you want to separate it and then you want to put it inside the run function. This is also the same place that you would put it if you were to initialize your Spark session, something that we can cover in another video. Okay, so I've been yip-yapping in a way. Let's go ahead and just run the thing. Let's take a look and let's see what happens, okay? I'm going to first scroll up a little bit here to make a bit of room. And then I'm also going to make sure that we can see the files as they populate. So we're going to open up our Finder here, and we have a data folder. So this is the folder that's pointed at the same thing. And now I'm going to click the Run button, but I do want to note one final thing. We're actually using a custom version of the Kedro CLI. And why are we using a custom version of the Kedro CLI? That's because the runner does not get specified programmatically inside of the context. In order for a runner to be specified, you need to modify the Kedro CLI on its run. So right here, for example, I have an extra function here that says streaming right here. I add that parameter using, it's basically your click API. It's a true false, it's a Boolean. And if it's true, then I use the streaming runner in order to specify that in the Kedro run. And to be honest, you could just override the context run in order to use your runner class. But I guess it depends on how you want to implement it. I personally put all of my CLI commands inside of the Kedro CLI just so I know where things are and there's no strangeness if I try to do like a context run in another case and I'm like overriding strange variables inside of the run. Okay, great. So let's go ahead and click that run button and we'll see it in action. So we're going to do Kedro run here. We're going to click that button and we get to watch and see. We're going to start the streaming service. You can see Kedro run dash dash streaming. It's using that new function parameter that I added. And it should be starting any moment. And while that's starting up, I'm going to go ahead and open up our file. So this is going to be the page which shows the last word graph. So this is the final graph that comes out after we run the pipeline. And so here we go. Pipeline has started. It's loading the configuration files, and it should be initializing our Twitter stream any moment. So the reason why it's showing up these notes is because of the way that we were starting up that stream, is since we were importing that. And as you can see, we're already saving a bunch of tweets. Here's a bunch of tweets that are going through, right? These are all the new tweets. Wow, it's really populating very fast. Let's see if we can scroll up a little bit here so you can see. So we got all of our raw tweets in the raw folder. And now check that out. The pipeline just ran. We've extracted all the words here. So these are our word extractions. And then we have our word counts and our first checkpoint and our first graph. And so if I reload the page right below me, you should see the first graph. And here it is. RT is the most popular thing to say, I for, and then hashtag Python due to. And there you have it. We have a real, semi-real time pipeline pulling the Twitter data, streaming it out into our system, and then Kedro is running in parallel to process all of the streaming in semi-real time. And so if I reload this page once more, we should see an updated version of the graph with higher counts. If we reload, and there it is, you see RT is the most popular word that is out there, and then the other ones just follow as suit. Oh man, this is such a great pipeline, and I really hope you guys enjoyed it. It took me a bit of time actually to get this guy prepared. So if you appreciate this kind of stuff, make sure you button that like, sub that scribe, and ring that ding if you want to know when we are pipelining. And tell me about the pipelines that you guys write. I really love reading about the stuff that you guys know. And if you guys have any questions, please, 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 just ask, ask, ask. I am so happy and thrilled when you guys ask questions that I can answer and that I can help you guys out with. And sometimes, maybe, I can also learn something too with you. So please, please, please don't forget to leave a comment, like, and subscribe to these videos. It really helps out a lot. Thanks again. I'll see you guys in the next one. Ciao, ciao. Bye bye.